Cities are becoming the new frontier for wildlife adaptation, and while most species struggle against concrete and crowds, certain primates possess a remarkable toolkit of intelligence, flexibility, and resilience that allows them not just to survive, but potentially thrive in these human-dominated landscapes. Think of a city as an ecosystem, not in the abstract sense, but as a genuine habitat with its own rhythms, resources, and rules. There are food sources, certainly, though they come in dumpsters and outdoor markets rather than fruit trees. There are predators, mostly mechanical ones with wheels and horns. There are vertical structures to navigate, social hierarchies to understand, and seasonal patterns dictated by human behavior rather than rainfall. Some primates, through a combination of cognitive ability, behavioral flexibility, and sheer adaptability, have demonstrated an unexpected capacity to decode these urban puzzles. This video ranks 5 primate species using specific, measurable survival criteria drawn from scientific research and documented urban encounters. You won't find sensationalism here, just calm analysis of what makes certain primates better equipped for city life than others. Each ranking is supported by field observations, peer-reviewed studies, and verified reports from cities where human-primate coexistence is already happening. To create a meaningful ranking, we need transparent criteria. City survival isn't about a single trait, but rather a complex interplay of abilities, each contributing to a primate's overall urban fitness. Here's how we'll evaluate each species. Diet flexibility receives a weight of 15%. Urban environments offer unpredictable food sources ranging from garbage bins to garden vegetables to handouts from well-meaning but misguided humans. Omnivorous primates that can switch between food types, remember productive foraging locations, and innovate new feeding strategies score higher. We're looking at documented cases of trash foraging, crop raiding in urban gardens, and the ability to exploit seasonal human food patterns. Problem solving and tool use carries 15% weight. Cities present novel challenges, locked containers, complex building layouts, human-made barriers. Primates that demonstrate innovation, learn from observation, and pass knowledge through social groups have measurable advantages. This includes everything from opening latches to using human infrastructure like water taps or exploiting architectural features for shelter. Locomotion and agility accounts for 10%. Urban landscapes demand versatility, the ability to climb vertical surfaces, traverse power lines, leap between buildings, and move efficiently on the ground through streets and alleys all matter. Species limited to specific movement patterns face serious constraints in cities. Tolerance of humans gets 15%. This is a delicate balance, too fearful, and a primate can't exploit urban resources. Too bold, and conflict becomes inevitable, often ending badly for the primate. We're evaluating behavioral plasticity, the capacity to habituate to human presence without becoming aggressive, and the ability to read and respond to human behavior cues. Social structure receives 10% weight. Urban primates benefit from cooperative foraging, social learning of safe routes and productive locations, and group vigilance against threats like vehicles. However, very large groups can attract negative attention. We're assessing how group size and organization contribute to urban survival. Reproductive rate carries 10%. Species that mature quickly and reproduce frequently can establish viable populations faster and recover from losses due to urban hazards like traffic, disease, or human persecution. We examine age at first birth, interbirth intervals, and potential for population growth in fragmented urban habitats. Disease and parasite tolerance gets 10% weight. Cities concentrate pathogens, especially where primates and humans interact. Species with robust immune responses and documented resistance to urban diseases score higher, though we must note that disease transmission can flow both directions, making this a public health concern. Activity timing receives 5%. The ability to shift foraging to dawn, dusk, or night helps primates avoid peak human activity, reducing conflict while still accessing resources. Behavioral flexibility in activity patterns provides measurable advantages. Range and climate tolerance accounts for 10%. Cities exist across temperature zones and seasons. Primates with broad thermal tolerance and the ability to find food year-round in variable climates adapt more successfully to diverse urban environments. Our composite score formula is straightforward. We rate each criterion from 0 to 10, multiply by the weight percentage, and sum the results for a total out of 100. This quantitative approach allows transparent comparison, while acknowledging that survival depends on multiple factors working together. One critical ethical note before we proceed. This video does not encourage feeding wild primates, keeping them as pets, or approaching them for close interaction. Urban coexistence requires respect, distance, and strategies that minimize conflict, while allowing both species to thrive in shared spaces. We considered 10 primate species with documented or plausible urban adaptability. Understanding why some didn't make our top 5 reveals as much as the rankings themselves. The rhesus macaque is perhaps Asia's most successful urban adapter, found in cities from India to China, exploiting temples, markets, and residential areas with remarkable skill. The long-tailed macaque, also called the crab-eating macaque, thrives near human settlements across Southeast Asia, and even uses stone tools in its foraging. The olive baboon appears along roadsides and in East African towns, leveraging size and group coordination for protection and resource access. Capuchin monkeys from Central and South America demonstrate exceptional tool use and problem-solving that theoretically suits urban life. Vervet monkeys raid gardens across sub-Saharan African cities with flexible diets and complex social systems. Chimpanzees possess the highest cognitive abilities of any non-human primate and occasionally raid crops near human settlements, but their large size, strength, and potential for serious conflict with humans when threatened keep them off our list. Bonnet macaques show urban familiarity throughout southern India, adapting to temple complexes and city margins. Ring-tailed lemurs from Madagascar have diverse diets and striking appearance, but face constraints from their island evolution and vulnerability to mainland predators, including feral dogs common in cities. Howler monkeys conserve energy through leaf eating and have distinctive vocalizations, but their specialized folivorous diet limits urban food options. Squirrel monkeys are agile and social, but highly sensitive to stress and disturbance, making chaotic urban environments challenging. Some species with impressive traits didn't make the top 5 due to single decisive limitations. Chimpanzees' conflict potential outweighs their intelligence. Howlers' dietary specialization restricts them to areas with specific vegetation. Squirrel monkeys lack the boldness and stress tolerance for bustling streets. Even strong candidates face the reality that successful urban adaptation requires no weak links in the survival chain. The bonnet macaque earns fifth place through steady competence across all criteria, rather than exceptional performance in any single area. Endemic to southern India, these medium-sized primates have been navigating the complex relationship between temple grounds, agricultural margins, and expanding urban areas for generations. Bonnet macaques typically live in groups of 15 to 30 individuals. Their native range spans the forests and agricultural landscapes of India's southern states. But they've demonstrated remarkable flexibility in exploiting urban margins. Unlike some macaque species that aggressively raid human areas, bonnet macaques often maintain a more careful balance, present but not overwhelming, visible but not constantly confrontational. This temperament serves them well in densely populated Indian cities where tolerance for wildlife varies considerably. Diet flexibility scores 7 out of 10. Bonnet macaques are omnivorous opportunists, consuming fruits, seeds, flowers, insects, and occasionally bird eggs. In urban settings, they've been documented foraging in temple offerings, raiding garbage bins with selective care, and exploiting seasonal crops in urban gardens. They show good food memory, returning to productive sites, and moderate innovation in accessing packaged foods. However, they're somewhat less versatile than their rhesus cousins, showing more conservative foraging patterns. Problem-solving and tool use rates 6 out of 10. These macaques demonstrate solid cognitive abilities including opening simple containers, manipulating objects to access food, and learning from conspecifics. They remember complex routes through urban areas and can navigate buildings to access rooftops or courtyards. Tool use remains limited to basic object manipulation rather than the sophisticated stone tool use seen in long-tailed macaques. Social learning helps groups collectively map productive foraging areas and avoid hazards. Locomotion and agility scores 8 out of 10. Bonnet macaques excel at movement. They're equally comfortable on the ground or in trees, can scale walls using minimal footholds, traverse power lines and cables with confidence, and leap between rooftops when necessary. This versatility allows them to exploit vertical urban landscapes effectively, accessing areas where food concentrates while using elevated routes to avoid ground-level dangers. Human tolerance rates 7 out of 10. Bonnet macaques generally maintain appropriate wariness of humans while still habituating enough to exploit urban resources. They read human body language reasonably well, retreating when threats escalate, but standing ground when holding food resources. Their relatively smaller size compared to rhesus macaques results in fewer serious conflicts, though bites and food theft still occur. Temple communities often tolerate them as part of the local religious landscape, providing a buffer of acceptance. Social structure scores 7 out of 10. Groups are cohesive without being unwieldy for urban settings. The matrilineal structure means experienced females pass down knowledge of productive foraging sites and safe routes. Dominance hierarchies reduce internal conflict, and group vigilance helps detect threats like dogs or vehicles. However, intergroup encounters can be aggressive, and territoriality sometimes limits population density in urban fragments. Reproductive rate receives 6 out of 10. Females typically first give birth around 4 to 5 years of age, with interbirth intervals of roughly 18 months. This moderate reproductive tempo allows steady population growth, but won't produce explosive colonization. Urban populations can maintain themselves and slowly expand, though recovery from significant losses takes time. Disease tolerance scores 6 out of 10. Bonnet macaques face typical primate susceptibilities, including parasites, respiratory infections, and gastrointestinal issues that can intensify in urban environments with concentrated waste and close human contact. They show reasonable resilience, but are not exceptionally robust compared to some other macaque species. Disease surveillance in Indian cities has documented various pathogens in urban bonnet macaque populations, requiring ongoing monitoring. Activity timing rates 5 out of 10. These macaques are predominantly diurnal, with peak activity during morning and late afternoon. They show limited flexibility in shifting to crepuscular or nocturnal patterns, which means they're active during peak human activity times. This increases encounter rates, but also opportunity for foraging when markets and food sources are most accessible. Range and climate tolerance scores 7 out of 10. Adapted to southern India's tropical and subtropical climates, bonnet macaques handle heat well and can find water in urban settings through taps, fountains, and artificial water sources. They're less tested in cold climates, but show reasonable seasonal flexibility within their range, adjusting foraging as fruit availability changes with monsoon patterns. Urban case notes paint the picture of cautious adaptation. In cities like Mysore and Bangalore, bonnet macaques occupy a niche in temple complexes and park edges. They've learned that certain times bring food offerings at temples, timing their visits accordingly. They've memorized routes through neighborhoods, knowing which gardens have fruiting trees and which residents will chase them away. When encountering locked garbage bins, they watch and learn from each other, with successful individuals teaching their group through observation. Conflicts typically involve crop damage in urban gardens and occasional food theft from outdoor markets or residential courtyards. Bites occur when humans attempt to retrieve stolen food or when animals feel cornered. Communities respond with mixed strategies. Some temples welcome them as sacred animals, while agricultural areas use non-lethal deterrents, like noisemakers or dogs. The moderate size and relatively manageable group sizes keep conflicts from escalating to the degree seen with larger primate species. Why not higher? Bonnet macaques lack the exceptional boldness and innovation of species ranking above them. Their problem-solving is competent but not creative. Their dietary flexibility is good but not extraordinary. They're solid generalists without standout specializations. They also face strong competition from rhesus macaques, where their ranges overlap, often losing in direct encounters. Why not lower? Their balanced competence across categories prevents them from falling further. They have no critical weakness that would disqualify them from urban life. Their moderate temperament actually reduces human persecution compared to more aggressive species, potentially improving long-term survival prospects. Composite score: 66 out of 100. One-line takeaway. The bonnet macaque succeeds in urban margins through steady adaptability and a temperament that maintains the delicate balance between exploiting human resources and avoiding fatal conflicts. Vervet monkeys claim fourth place through a combination of dietary flexibility, social intelligence, and remarkable adaptability to human-altered African landscapes. These medium-sized primates with distinctive black faces framed by white fur have become familiar figures in cities and towns across sub-Saharan Africa. Vervets typically form groups of 10 to 50 individuals with multi-male, multi-female compositions and matrilineal social structures. Their native range spans savanna woodlands and riverine forests from South Africa to Ethiopia, but their comfort with edge habitats has made them natural exploiters of urban margins. In cities like Cape Town, Nairobi, and the Kampala, vervets have established populations that navigate the interface between green spaces and human development with practiced ease. Diet flexibility scores 8 out of 10. Vervets are confirmed opportunistic omnivores with documented consumption of fruits, flowers, seeds, leaves, insects, bird eggs, and even small vertebrates. Urban vervets have proven exceptionally versatile, raiding gardens for vegetables, exploiting fruit trees in residential areas, scavenging from garbage bins, and even stealing food directly from outdoor dining areas. They show excellent food memory and have been observed teaching foraging techniques within groups. Studies from South African suburbs document vervets consuming over 70 different food types, including numerous introduced plant species. Problem solving and tool use rates 7 out of 10. Vervets demonstrate solid cognitive abilities, including opening containers with latches, pulling apart packaging, and manipulating objects to access food. They're particularly adept at social learning, with entire groups rapidly acquiring new foraging techniques when innovative individuals discover solutions. Their famous alarm call system, with specific vocalizations for different predators like leopards, eagles, and snakes, demonstrates sophisticated cognitive processing that extends to urban threat assessment. They've learned to distinguish between humans who chase them and those who ignore them, modifying their behavior accordingly. Locomotion and agility scores 8 out of 10. Vervets are highly competent climbers and leapers, moving confidently through trees and along branches. On the ground, they're quick and agile, capable of rapid sprints when necessary. In urban environments, they scale fences and walls, traverse power lines, and use building ledges and rooftops as travel corridors. Their moderate size gives them access to structures that wouldn't support larger primates while maintaining enough strength and reach for impressive athletic feats. Human tolerance rates 6 out of 10. This is where vervets show more variability. Some populations become remarkably bold, approaching humans closely, and even stealing food from hands or tables. Others maintain more cautious distance. The boldness can work against them, as aggressive food-seeking behavior generates strong negative reactions from humans. Cases of vervets biting people when food is involved, while not common, damage community tolerance. Their tendency to raid gardens and damage property makes them controversial neighbors. However, their small size, relative to baboons, means conflicts rarely result in serious human injuries, maintaining a level of grudging acceptance. Social structure scores 8 out of 10. Vervet social dynamics are sophisticated. Matrilineal groups maintain knowledge across generations about productive foraging sites, safe routes, and threat assessment. Studies have demonstrated that vervets engage in complex social relationships, including alliances, reciprocal grooming, and even apparent food sharing. In urban settings, this social complexity translates to efficient information transfer about new food sources, dangers like traffic patterns and human behaviors. Group sizes in urban areas sometimes grow larger than forest populations, suggesting that resource abundance can support higher densities despite some costs of crowding. Reproductive rate scores 7 out of 10. Female vervets typically reach sexual maturity around 3 to 4 years and can produce offspring annually with gestation periods of roughly 5.5 months. This relatively rapid reproductive rate allows populations to grow and recover from losses. Urban populations with abundant food sometimes show reduced interbirth intervals, accelerating population growth. The combination of early maturity and annual breeding provides good colonization potential. Disease tolerance rates 5 out of 10. Vervets face documented disease challenges in urban areas, including intestinal parasites exacerbated by garbage consumption, respiratory infections, and various pathogens associated with close human contact. They're susceptible to some of the same diseases affecting humans, making disease transmission a bidirectional concern. Urban populations show higher parasite loads than their forest counterparts in several studied systems. However, they're not exceptionally vulnerable, and populations persist despite disease pressures. Activity timing scores 6 out of 10. Vervets are primarily diurnal, but show some flexibility, with urban populations documented foraging during early morning and late afternoon to avoid peak human activity during midday heat. This partial temporal shifting reduces direct encounters, while still allowing access to resources during daylight when visual foraging is most effective. Some populations have learned to time raids on gardens and outdoor food sources to coincide with human absence patterns. Range and climate tolerance scores 7 out of 10. Vervets occur across a wide range of African climates, from tropical to temperate regions. They handle both heat and moderate cold, though they're less adapted to temperature extremes than some species. Their ability to exploit diverse habitats from coastal areas to highland regions suggests good ecological flexibility. Water needs are moderate, and they readily use artificial water sources in urban areas, including pools, fountains, and garden irrigation. Urban case notes reveal vervets as confident urban exploiters. In Cape Town suburbs, troops have memorized garbage collection schedules, appearing in neighborhoods on collection days to forage before trucks arrive. They've learned which houses have dog doors that provide access to kitchens, leading to sophisticated home invasions for food. In Kenyan towns, vervets exploit hotel grounds and restaurants, with some individuals becoming remarkably skilled at snatching food from outdoor diners. Young vervets learn these behaviors through observation, creating cultural transmission of urban survival skills. Conflicts center on property damage and crop raiding. Homeowners report damaged gardens, broken roof tiles where troops cross, and occasional home invasions. The vervet's tendency to tear open garbage bags creates mess that attracts other scavengers. Bites occur when humans attempt to chase them away or recover stolen items. Communities employ various strategies including guard dogs, physical barriers, and noise deterrence with mixed success. Some areas resort to trapping and relocation, though this often proves ineffective as new troops move into vacated territories or relocated animals return. Why not hire? Vervets excel in many categories, but lack the exceptional problem-solving abilities and tool use of higher-ranked species. Their disease susceptibility is notable, and their boldness sometimes works against them by generating human backlash. They also face predation pressure in urban areas from dogs, a vulnerability that larger primates don't share to the same degree. Why not lower? Their dietary flexibility and social intelligence are impressive. Their reproductive rate ensures population persistence. Most importantly, they've demonstrated sustained success in numerous African cities across diverse conditions, proving their adaptation isn't limited to specific local circumstances, but represents true urban competence. Composite score, 69 out of 100. One-line takeaway. Vervet monkeys combine opportunistic omnivory with social learning and behavioral flexibility, creating urban populations that persist despite generating significant human conflict through their boldness and garden-raiding habits. The olive baboon captures third place through a potent combination of size, intelligence, social complexity, and an almost fearless approach to human spaces. These large, powerful primates have increasingly appeared in East African towns and cities, creating both fascination and significant management challenges. Olive baboons form large, complex troops, typically numbering 20 to 150 individuals, though urban populations sometimes fragment into smaller subgroups that can navigate city spaces more efficiently. Their native range spans the African savanna belt from Mali to Ethiopia and south to Tanzania. Adult males can weigh 30 kilograms or more, making them among the largest monkeys and physically capable of defending themselves against most threats, including dogs and even humans. This size brings both advantages and complications for urban life. Diet flexibility scores 9 out of 10. Baboons are supremely opportunistic omnivores, with documented consumption of fruits, seeds, tubers, flowers, grass, insects, bird eggs, small mammals, and reptiles. Urban baboons have proven spectacularly versatile, raiding agricultural crops, scavenging from garbage dumps, breaking into parked vehicles to steal food, entering homes through windows or doors, and even hunting small domestic animals like chickens. Studies from Kenyan and South African urban areas document baboons consuming over 100 different food types, including highly processed human foods. They show excellent spatial memory for productive foraging sites and temporal memory for patterns like market days or garbage collection schedules. Problem solving and tool use rates 8 out of 10. Baboons demonstrate sophisticated cognition. They've been observed opening car doors, manipulating complex latches, removing roof panels to access stored food, and even turning on outdoor taps for water. Their ability to learn from observation means innovative behaviors spread rapidly through troops. They understand cause and effect relationships, can plan multi-step solutions to foraging challenges, and show remarkable persistence when facing obstacles. While they don't use stone tools like some macaques, their manipulative abilities and problem-solving flexibility approach the capabilities of great apes. Locomotion and agility scores 7 out of 10. Despite their size, olive baboons are competent climbers and surprisingly agile. They move confidently on the ground, can scale walls and fences, climb trees and buildings, and leap impressive distances when necessary. However, their bulk limits access to smaller structures and thinner branches compared to lighter primates. In urban settings, they primarily use ground roots but can exploit rooftops and walls when needed. Their powerful limbs allow them to force open barriers and move heavy objects, a unique capability among urban primates. Human tolerance rates 5 out of 10. Here's where baboons face their greatest challenge. Their size and strength make them genuinely intimidating. Adult males with prominent canine teeth can be frightening even when not being aggressive. Baboons habituated to humans often show remarkably bold behavior, approaching closely, grabbing food, and standing their ground in confrontations. This boldness sometimes escalates to actual aggression, particularly when food is involved, or when humans attempt to chase them away. Reports of baboons breaking into homes, threatening residents, and causing significant property damage generate intense negative reactions. Their capacity to inflict serious bites means conflicts can have severe consequences. This tension limits human tolerance despite their intelligence and adaptability. Social structure scores 9 out of 10. Baboon societies are among the most complex in the primate world. They maintain intricate dominance hierarchies, form coalitions, demonstrate political maneuvering, and exhibit long-term social bonds. In urban contexts, this social sophistication translates to coordinated group foraging, with sentinels watching for threats while others raid food sources. Social learning accelerates the spread of urban survival skills through troops. Experienced individuals teach routes, techniques, and threat assessment to younger members. The multi-male structure means troops can defend themselves collectively against dogs, or even hostile humans. However, large group sizes can overwhelm small urban areas, and inter-troop conflicts can be intense and disruptive. Reproductive rate scores 6 out of 10. Female baboons typically reach sexual maturity around 5 to 6 years, with interbirth intervals of roughly 2 years. This moderate reproductive tempo, combined with relatively long lifespans of 20 to 30 years, means populations grow steadily, but not explosively. Urban populations with enhanced nutrition sometimes show slightly reduced interbirth intervals. The long juvenile period allows extensive social learning, beneficial for acquiring urban survival skills, but slows population expansion. Disease tolerance scores 6 out of 10. Baboons face disease challenges in urban environments, including gastrointestinal parasites from garbage consumption, injuries from vehicles and conflicts, and various pathogens. Their close genetic relationship to humans means they're susceptible to many of the same diseases, creating bi-directional health concerns. Studies from urban baboon populations document parasites, bacterial infections, and occasional outbreaks of diseases that can jump to humans. However, they're reasonably robust, and most individuals survive these challenges. Activity timing scores 5 out of 10. Olive baboons are strictly diurnal, with activity concentrated during daylight hours. They show limited temporal flexibility, remaining active during peak human activity times. This increases encounter rates and conflict potential. However, their boldness means they forage effectively despite human presence, somewhat offsetting the lack of temporal avoidance strategies. Range and climate tolerance scores 8 out of 10. Baboons occur across diverse African environments, from savanna to highland regions. They tolerate both heat and moderate cold, handle seasonal variation in food availability, and adjust their ranging patterns to exploit temporary resources. Water requirements are moderate, and they readily use artificial sources. This ecological flexibility means they can potentially colonize cities across a wide geographic and climatic range. Urban case notes document baboons as formidable urban adapters. In towns near Kenyan national parks, troops have learned to raid tourist facilities, timing their visits when food is prepared and staff distracted. They've memorized which houses have easily breached security, returning repeatedly despite deterrence. In South African suburbs near nature reserves, baboons enter homes through open windows, systematically searching for food while residents hide in other rooms. They've learned to open refrigerators, manipulate food containers, and even turn on water taps when thirsty. Conflicts are frequent and significant. Property damage includes broken windows, torn screens, damaged roofs, and destroyed gardens. Aggressive encounters result in bites that sometimes require medical treatment. Troops moving through neighborhoods can disrupt daily life, with residents afraid to leave homes during baboon raids. The economic costs include direct property damage, loss of crops, and stored food, and impacts on tourism, when baboons harass visitors. Management responses range from non-lethal deterrents, like paintball markers and bear bangers, to physical barriers and, in extreme cases, lethal control of particularly problematic individuals. Why not higher? The conflict issue is decisive. Baboons generate more negative human reactions than smaller primates due to their size, strength, and capacity for property damage and potential harm. In many urban contexts, this conflict limits their long-term viability. Authorities face pressure to remove or eliminate urban baboon populations, making their urban future uncertain despite their impressive adaptability. Their strict diurnal activity also increases human encounters compared to species with temporal flexibility. Why not lower? Their cognitive abilities, dietary flexibility, and social complexity are exceptional. They're genuine problem solvers with remarkable persistence and learning capacity. In contexts where human tolerance can be maintained through proper waste management and architectural deterrence, baboons demonstrate urban competence that rivals any primate. Their success in multiple East African towns proves their adaptation isn't fluky, but reflects genuine capability. Composite score: 73 out of 100. One-line takeaway: olive baboons possess the intelligence, strength, and social sophistication to dominate urban environments. But their size and boldness generate human conflicts that threaten their long-term viability in cities, despite their impressive adaptive capabilities. The long-tailed macaque, also called the crab-eating macaque, secures second place through exceptional versatility, documented tool use, and proven success in some of Southeast Asia's most densely populated urban areas. These medium-sized primates have become such urban fixtures in parts of their range that entire tourist industries have developed around their temple populations. Long-tailed macaques typically live in groups of 20 to 60 individuals with multi-male, multi-female structures and matrilineal social organization. Their native range spans Southeast Asia, from Myanmar through the Malay Peninsula to the Philippines and Indonesia. They've proven remarkably successful at colonizing islands and coastal areas, with some populations even swimming between islands, demonstrating exceptional ecological flexibility. In cities like Bangkok, Bali, Singapore, and numerous other Southeast Asian urban centers, they've established thriving populations that navigate complex relationships with human residents and tourists. Diet flexibility scores 9 out of 10. The common name crab-eating macaque hints at their dietary breadth, though crabs are just one of dozens of food types they consume. Wild populations eat fruits, seeds, flowers, leaves, insects, bird eggs, small vertebrates, and yes, crabs and other marine invertebrates. Urban populations have added extensive lists of human foods, agricultural crops, and garbage-derived items. They've been documented raiding markets, stealing food from restaurants and homes, exploiting temple offerings, and scavenging from garbage with impressive efficiency. Some coastal urban populations maintain their crab-eating behavior, foraging in intertidal zones, even while exploiting nearby human food sources. Their dietary eclecticism means they can survive on whatever a particular urban environment provides. Problem-solving and tool use rates 9 out of 10. This is where long-tailed macaques truly shine. They're the only old-world monkeys documented using stone tools in their natural behavior, with coastal populations in Thailand using rocks to crack open shellfish and nuts. This tool use isn't instinctive but learned and transmitted culturally within populations. Urban populations demonstrate equally impressive problem-solving, opening complex latches and containers, manipulating zippers and bags, even stealing and using human objects. Famous temple populations have learned to steal tourists' belongings like glasses and phones, then refuse to return them unless offered food in exchange, demonstrating an understanding of object value and exchange that approaches trade behavior. Their observational learning is exceptional, with new foraging techniques spreading rapidly through groups. Locomotion and agility scores 8 out of 10. Long-tailed macaques are highly competent in trees, on the ground, and surprisingly in water. They swim well, an unusual ability that has allowed them to colonize islands and exploit coastal resources. In urban environments, they scale buildings, traverse power lines, leap between structures, and move confidently across diverse substrates. Their long tails, while not fully prehensile, aid in balance during complex climbing. This movement versatility allows them to exploit three-dimensional urban landscapes effectively. Human tolerance rates 7 out of 10. Long-tailed macaques show excellent behavioral plasticity in their interactions with humans. Temple populations habituate to constant tourist presence, approaching closely without excessive aggression. They've learned to distinguish between locals and tourists, often behaving more boldly with visitors. However, this boldness is calibrated. They retreat when threatened and generally avoid escalating conflicts. Their moderate size means most interactions don't result in serious injury, though bites do occur. Importantly, some Southeast Asian cultures have religious or traditional acceptance of macaques, particularly in temple contexts, providing a cultural buffer of tolerance that wouldn't exist elsewhere. This cultural factor significantly enhances their urban viability in their native range. Social structure scores 8 out of 10. Like other macaques, long-tailed macaques maintain matrilineal societies with clear dominance hierarchies and multi-generational knowledge transfer. Urban populations benefit from social learning of productive foraging sites, safe routes, and effective foraging techniques. Group living provides vigilance against threats and coordinated foraging. Dominance hierarchies reduce internal conflict, allowing efficient resource exploitation. Group sizes in urban areas sometimes adjust to available resources, with populations fragmenting or consolidating based on food distribution. Reproductive rate scores 7 out of 10. Females typically reach sexual maturity around 4 years, with interbirth intervals of roughly 15 to 18 months. This fairly rapid reproductive rate allows populations to grow and recover from losses. Urban populations with enhanced nutrition sometimes show reduced interbirth intervals. The combination of moderate generation time and consistent reproduction provides good population viability. Studies of island colonization by long-tailed macaques show they can establish viable populations from small founder groups within a few generations. Disease tolerance scores 6 out of 10. Long-tailed macaques face health challenges in urban environments, including parasites, bacterial infections, and injuries. Their extensive use in biomedical research stems partly from their physiological similarity to humans, meaning they share disease susceptibilities. Urban populations show elevated parasite loads, and some populations carry pathogens of concern for zoonotic transmission. However, they're generally robust, and most individuals survive typical urban disease pressures. Longevity studies suggest urban individuals can live 15 to 25 years despite these challenges. Activity timing scores 6 out of 10. Long-tailed macaques are primarily diurnal, but show more temporal flexibility than some primates. Urban populations have been documented adjusting activity patterns with increased early morning and late afternoon foraging when human activity is lower. Some populations extend activity into twilight periods, particularly when exploiting resources like night markets. This moderate flexibility helps them balance resource access with conflict avoidance. Range and climate tolerance scores 8 out of 10. Long-tailed macaques occur from tropical rainforests to coastal scrublands across diverse temperature and rainfall regimes. They handle heat well, have moderate water needs, and adjust to seasonal variation in food availability. Their ability to exploit both terrestrial and coastal resources provides multiple options in urban settings. They've successfully colonized islands with varying climates, demonstrating ecological flexibility that translates well to diverse urban environments. Urban case notes reveal long-tailed macaques as sophisticated urban operators. In Ubud, Bali, temple macaques have developed elaborate strategies for obtaining food. They steal sunglasses, phones, or other valuable objects from tourists, retreat to safe positions, then wait for food offerings in exchange for returns. This behavior is learned and practiced, with young macaques observing and gradually participating. In Thai coastal cities, macaques forage at fresh markets during early morning hours when seafood is delivered, stealing fish and shellfish. They've learned to distinguish between vendors who chase them and those who ignore them, adjusting their boldness accordingly. Thai research teams have documented remarkable problem-solving in urban long-tailed macaques. They open car doors, unzip backpacks, manipulate complex container closures, and even work cooperatively with some individuals, distracting humans, while others grab food. Their stone tool use has been documented in urban contexts, with individuals bringing rocks to coastal areas where shellfish concentrate to crack open shells efficiently. Conflicts involve food theft, property damage, and occasional bites. Their boldness sometimes crosses into aggression, particularly during breeding season when hormones intensify behavior. Crop damage in agricultural areas adjacent to cities generates economic losses. Management strategies include physical barriers around vulnerable food sources, designated feeding areas to concentrate populations, and non-lethal deterrence. Temple populations exist in semi-managed states where feeding is regulated and health monitoring conducted. Why not higher? While long-tailed macaques excel in most categories, they face competition from one species that matches their cognitive abilities while showing even greater behavioral flexibility and arguably better human tolerance calibration. Their disease profile, while manageable, presents more concerns than the top-ranked species. In regions outside their native Southeast Asian range, cultural tolerance would be lower, limiting their potential global urban success compared to a species with broader cultural acceptance. Why not lower? Their tool use, problem-solving abilities, and dietary flexibility are exceptional. They've proven their urban competence across dozens of cities in multiple countries. Their reproductive rate ensures population persistence. Most importantly, they've achieved something rare: cultural integration in some urban areas, where they're accepted, managed, and even celebrated as part of local identity. This represents a sustainable model of human-primate urban coexistence. Composite score, 77 out of 100. One-line takeaway: long-tailed macaques combine exceptional cognitive abilities, including tool use, dietary versatility, and behavioral plasticity, to thrive in Southeast Asian urban environments where cultural tolerance and proven problem-solving skills create sustainable, if sometimes contentious, coexistence with human populations. The rhesus macaque claims first place through a combination of proven urban success across the broadest geographic range, robust health, exceptional dietary and behavioral flexibility, and a temperament that balances boldness with calibrated responses to human behavior. These medium-sized primates haven't just adapted to cities. In much of South and Southeast Asia, they've become defining features of urban landscapes. Rhesus macaques live in multi-male, multi-female troops, typically numbering 20 to 200 individuals, with urban populations sometimes forming even larger aggregations where food resources concentrate. Their native range spans from Afghanistan through India to China and Southeast Asia, making them the most geographically widespread non-human primate. Crucially, this range includes some of the world's most densely populated regions, meaning rhesus macaques have been navigating human-dominated landscapes for millennia. In cities throughout their range, from New Delhi to Beijing, from Kathmandu to Hong Kong, rhesus macaque populations number in the thousands, demonstrating sustained urban viability across diverse cultural and environmental contexts. Diet flexibility scores 10 out of 10. Rhesus macaques are omnivorous opportunists, with perhaps the most diverse diet documented for any primate. Wild populations consume fruits, seeds, roots, bark, flowers, leaves, insects, bird eggs, and small vertebrates. Urban populations have exponentially expanded this list. They exploit agricultural crops, raid garbage efficiently, steal food from markets and homes, consume processed human foods, including bread, cooked rice, and packaged snacks, and even adjust their preferences based on seasonal availability and local patterns. Studies from Indian cities document rhesus macaques consuming over 120 different food types across seasons. They show exceptional spatial and temporal memory for food sources, remembering productive foraging locations, and timing their visits to coincide with food availability patterns like market days or temple offerings. Most impressively, they demonstrate food neophilia, the willingness to try novel foods, combined with rapid social learning that spreads successful foraging innovations through troops within days. Problem-solving and tool use rates 9 out of 10. Rhesus macaques demonstrate sophisticated cognition across multiple domains. They solve novel problems, including opening complex containers, manipulating latches and locks, and planning multi-step routes to access food. Their observational learning is excellent, with individuals rapidly acquiring new foraging techniques by watching successful troop members. They understand basic cause and effect relationships, demonstrated through experiments and field observations of their manipulation of human infrastructure. Urban rhesus macaques have been documented turning on water taps during droughts, opening car doors and windows to access food inside, removing roof tiles to enter attics, and even manipulating smartphone screens when stolen devices are dropped. While they don't regularly use stone tools like long-tailed macaques, their problem-solving flexibility across diverse challenges is exceptional. They also show remarkable memory, with studies demonstrating they remember individual humans and respond differently based on past interactions. Locomotion and agility scores 8 out of 10. Rhesus macaques are versatile athletes, equally comfortable in trees or on the ground. They're strong climbers, capable leapers, and surprisingly fast runners when necessary. In urban environments, they scale buildings using minimal footholds, traverse power lines with confidence, leap between rooftops, and move through complex three-dimensional structures with practiced ease. Their moderate size provides a good balance. They're large enough to move obstacles and defend themselves, but small enough to access diverse structures. This movement versatility allows them to exploit food sources that require complex navigation and escape routes when conflicts arise. Human tolerance rates 8 out of 10. This might be rhesus macaques' most crucial advantage. They show exceptional behavioral plasticity in human interactions, a calibrated boldness that varies with context. They approach humans confidently when opportunities arise, but generally retreat when faced with genuine threats. They've learned to read human body language, distinguishing between people who will chase them and those who won't, between those carrying potential food and those without. Most importantly, they modulate their aggression. While bites occur, particularly during resource competition or breeding season, rhesus macaques generally avoid escalating conflicts unnecessarily. Their size means they're not as physically intimidating as baboons, reducing extreme human fear responses. Culturally, Hindu religious traditions in much of their range accord them sacred status, connected to the monkey god Hanuman, providing a significant buffer of tolerance. Even in regions without this religious context, long coexistence has created grudging acceptance of their presence. They're considered nuisances rather than threats in most urban areas, a crucial distinction for long-term viability. Social structure scores 9 out of 10. Rhesus macaque societies are complex and hierarchical. Matrilineal groups pass knowledge across generations about productive foraging areas, safe routes through urban landscapes, and effective strategies for exploiting human resources. Dominance hierarchies are clear and generally reduce internal conflict over resources. Multi-male groups provide collective vigilance and protection. Social learning is efficient, with innovation spreading rapidly. Urban troops demonstrate coordinated foraging, with sentinels watching for threats while others raid food sources. Inter-individual relationships include long-term bonds, alliances, and reciprocal interactions that strengthen group cohesion. This social sophistication translates directly to urban success through collective problem-solving and knowledge accumulation. Reproductive rate scores 7 out of 10. Female rhesus macaques typically reach sexual maturity around 3 to 4 years, with breeding seasons influenced by latitude and climate. Interbirth intervals average roughly 15 to 24 months depending on food availability. Urban populations with enhanced nutrition often show reduced interbirth intervals and higher survival of juveniles to maturity. This moderately rapid reproductive rate allows populations to grow steadily and recover from losses. Combined with lifespans that can exceed 25 years in favorable conditions, rhesus macaques have solid demographic potential for establishing and maintaining urban populations. Disease tolerance scores 8 out of 10. Here's a critical advantage. Rhesus macaques show robust health despite urban disease pressures. Their extensive use in biomedical research provides detailed knowledge of their disease susceptibilities and immune responses. While they carry parasites and can contract various infections, field studies of urban populations document relatively good health outcomes. They've coexisted with humans across their range, for thousands of years, potentially allowing evolutionary adaptation to shared pathogens. Monitoring programs in Indian cities show that while urban rhesus macaques face health challenges, population-level impacts are manageable. Their disease tolerance isn't perfect, but it's notably better than many primate species, contributing to sustained population viability in urban environments. Activity timing scores 6 out of 10. Rhesus macaques are primarily diurnal, with peak activity during morning and afternoon. They show moderate flexibility, with urban populations documented extending activity into early morning and dusk periods, particularly during summer heat when midday foraging is uncomfortable. Some populations adjust timing based on human patterns, raiding food sources when human activity is lower. This moderate temporal flexibility helps balance resource access with conflict avoidance, though they remain predominantly active during daylight. Range and climate tolerance scores 10 out of 10. Perhaps no other primate matches rhesus macaques' environmental flexibility. They occur from tropical lowlands to Himalayan highlands at elevations exceeding 4,000 meters, experiencing temperature ranges from below freezing to extreme heat. They handle monsoonal rainfall variation, seasonal food scarcity, and diverse habitat types from forests to deserts to urban centers. Urban populations demonstrate this flexibility, thriving in cities with cold winters like Beijing and hot cities like Delhi. They're physiologically adapted for thermal regulation across wide temperature ranges, can find water in varied conditions, and adjust their activity patterns seasonally. This environmental flexibility means rhesus macaques could potentially colonize cities across a wider geographic range than any other primate, limited only by their native range rather than climate constraints. Urban case notes reveal rhesus macaques as premier urban adapters. In Delhi, populations estimated at tens of thousands navigate the sprawling metropolitan area with complete confidence. They've memorized complex urban geography, knowing productive foraging routes through neighborhoods and safe sleeping sites in trees, buildings, and temples. They time visits to markets for opening hours, raid garbage bins systematically, and exploit seasonal patterns like religious festivals when food offerings increase. Research in Kathmandu documented remarkable problem-solving. Rhesus macaques learned to open zippered backpacks by watching tourists, spread the technique through troops within weeks, and now target tourists specifically for backpack raids. They distinguish between plastic bottles with screw tops and flip tops, using appropriate manipulation techniques for each. When encountering closed doors or windows, they systematically test for weaknesses rather than giving up immediately. Chinese studies revealed that urban rhesus macaques in some cities have learned to use crosswalks, waiting for traffic to stop before crossing streets. They respond to traffic lights and traffic patterns, demonstrating learned responses to urban infrastructure. Japanese research on rhesus macaques near cities documented food washing behavior, with individuals rinsing stolen produce in water fountains or streams before eating, a cultural practice transmitted socially. Conflicts are frequent but manageable. Food theft, crop raiding in urban gardens, and property damage generate ongoing tensions. Bites occur during resource disputes or when humans attempt to retrieve stolen items. In some areas, aggressive individuals or troops become severe nuisances, requiring management interventions. However, the scale of rhesus macaque urban populations, sustained across decades in multiple cities, suggests conflicts remain within tolerable bounds for most communities. Management strategies vary culturally and regionally. Some areas employ temple feeding programs that concentrate populations in managed locations. Others use physical barriers like electric fences around gardens or vulnerable buildings. Non-lethal deterrents, including noisemakers, water sprayers, and trained dogs, provide temporary relief. Some cities have implemented sterilization programs attempting population control, with mixed results. Capture and relocation faces challenges, as relocated individuals often return, or new troops move into vacated territories. Why not lower? Rhesus macaques excel across virtually every criterion. Their geographic range, proven urban success in dozens of cities, dietary flexibility, cognitive abilities, social complexity, and health robustness create a profile unmatched by other primates. They've achieved sustained urban populations that persist across generations, reproduce successfully, and maintain themselves despite human conflicts. They represent the gold standard of urban primate adaptation. The comparison to second-place long-tailed macaques highlights subtle advantages. While long-tailed macaques match cognitive abilities and show impressive tool use, rhesus macaques demonstrate slightly better health, broader climate tolerance, and most crucially, sustained success across a wider geographic range with larger total urban populations. Their religious significance in Hindu cultures provides tolerance that long-tailed macaques enjoy in some areas, but not throughout their range. Composite score, 82 out of 100. One-line takeaway. The rhesus macaque achieves premier urban primate status through unmatched geographic success, spanning diverse climates, exceptional dietary and behavioral flexibility, robust health, and a temperament that balances resource exploitation with calibrated responses to humans, creating sustained populations in some of Asia's largest cities. 3 species deserve mention as potential urban adapters under specific circumstances, each held back by single decisive factors that keep them from the top 5. The capuchin monkeys of Central and South America possess cognitive abilities rivaling any primate. They use tools extensively in wild populations, demonstrate innovative problem-solving, and show remarkable behavioral flexibility. Their dietary breadth includes fruits, insects, small vertebrates, and considerable opportunism. They're agile, coordinated, and highly social. So why aren't they ranked? The critical factor is human tolerance in their geographic range. Unlike Asia, where macaque populations benefit from religious tolerance and long cultural familiarity, capuchins face different cultural attitudes in the Americas. They're often associated with illegal pet trade, generating negative perceptions. Urban areas in their range have less tradition of large primate populations, meaning tolerance infrastructure doesn't exist. With appropriate cultural acceptance and urban planning that accommodated them, capuchins would rank among the top urban primates. Their exclusion reflects cultural and historical factors, rather than biological limitations. The chimpanzee represents an interesting thought experiment. These great apes possess the highest cognitive abilities of any non-human primate. They use complex tools, demonstrate abstract thinking, show cultural learning, and have social complexity approaching human societies. They're omnivorous, adaptable, and physically formidable. Yet no one seriously proposes chimpanzees as successful urban adapters. The decisive factor is conflict risk. Adult chimpanzees, particularly males, are extraordinarily strong, capable of inflicting severe injuries or death to humans. Their size and strength make any aggressive encounter potentially catastrophic. Human tolerance for animals capable of such harm in urban settings simply doesn't exist, nor should it. Even isolated conflict incidents would trigger immediate removal or lethal control. Chimpanzees exemplify how a single overwhelming negative trait can disqualify an otherwise capable species from urban viability. The bonnet macaque's close relative, the toque macaque of Sri Lanka, represents the geographic constraint factor. Toque macaques show comparable abilities to bonnet macaques in cognition, diet flexibility, and social complexity. In their native Sri Lankan range, they've successfully exploited temple areas and urban margins. However, their geographic restriction to a single small island nation limits their total urban impact. If toque macaques had continental range like rhesus macaques, they might rank higher. Their exclusion highlights how biogeography influences urban primate success beyond purely biological traits. Range size determines the number and diversity of urban environments available for colonization, affecting overall success in ranking considerations. These near misses remind us that urban adaptability depends on complex interactions between biological traits, cultural factors, and historical circumstances. A species' potential and its realized success can diverge significantly based on factors beyond individual capability. The presence of primates in cities creates real challenges, requiring thoughtful, humane approaches from both urban planners and residents. Successful coexistence depends on strategies that reduce conflict while respecting the animal's welfare and ecological roles. Cities can implement structural measures that minimize human-primate conflicts without harming animals. Secure garbage management stands as perhaps the single most effective intervention. Enclosed trash bins with primate-proof latches, regular collection schedules that don't leave waste exposed overnight, and centralized waste stations rather than scattered bins all reduce foraging opportunities that draw primates into human spaces. This approach addresses root causes rather than treating symptoms. Architectural design can incorporate wildlife proofing during construction. Screens on windows, secure door latches, roof designs that prevent primate access, and elimination of climbing aids near sensitive structures all help. For existing buildings, retrofitting vulnerable access points provides protection. These physical barriers work passively, without requiring ongoing intervention or causing animal harm. Green space design matters. Creating buffer zones with natural food sources at urban edges can reduce incentives for primates to penetrate deeper into human-dominated areas. These zones should connect to larger habitat patches when possible, providing movement corridors. However, provisioning in these areas should be avoided, as artificial feeding concentrates populations and increases human dependency, worsening rather than solving conflicts. Non-lethal deterrents provide temporary relief during acute conflicts. Noisemakers, water sprayers, trained dogs, and other aversive but harmless methods can move animals from specific vulnerable situations. However, primates habituate to consistent deterrence, requiring rotation of methods and understanding that these are stopgap measures rather than solutions. Residents bear responsibility too. Never feed wild primates, regardless of how entertaining or photogenic it might seem. Feeding creates dangerous habituation, associates humans directly with food, and can lead to aggression when offerings aren't forthcoming. It also disrupts natural foraging, can cause nutritional problems, and concentrates populations in ways that increase disease transmission. Maintain secure homes. Close windows and doors when primates are present in neighborhoods. Store food in closed containers and refrigerators. Don't leave bags or backpacks unattended in areas where primates forage. These simple precautions prevent most direct conflicts. Resist the urge for close selfies or interaction. Primates can be unpredictable, and close approach increases bite risk. They may perceive cameras and phones as threatening or as potential food sources. Maintain respectful distance. If a primate approaches you, stay calm. Avoid direct eye contact, which can be perceived as challenging. Slowly back away, and don't reach for or try to retrieve stolen items. Property is replaceable. Injuries from bites can be serious. Public health considerations require ongoing attention. Primates and humans share diseases. If bitten, seek immediate medical treatment. Rabies risk exists in some regions, though primates are not primary vectors. More commonly, bacterial infections from bites require antibiotic treatment. Report primate bites to health authorities who track potential disease transmission patterns. Tourism involving urban primates requires ethical guidelines. Responsible tourism maintains distance, avoids feeding, and contributes to conservation and management programs through fees that support urban wildlife management. Exploitative practices that stress animals or encourage problematic habituation should be avoided and reported. Ultimately, urban coexistence succeeds when humans accept responsibility for creating conditions that make our cities livable for ourselves and for the wildlife we've displaced. Primates in cities aren't invaders. They're responding to ecological opportunities we've inadvertently created. Our responses should reflect this understanding, balancing legitimate human needs with humane treatment and recognition of these remarkable animals' cognitive and emotional complexity. Our evidence-based ranking reveals 5 primate species with demonstrated urban competence, each bringing unique strengths to city survival. At number 5, the bonnet macaque succeeds through balanced, moderate abilities across all categories and a temperament that maintains workable relationships with humans in southern Indian urban areas. Number 4 goes to the vervet monkey, whose dietary flexibility, social intelligence, and proven adaptation to African cities demonstrate robust urban capability despite generating significant human conflict through garden raiding. The olive baboon ranks 3rd with exceptional cognitive abilities, dietary versatility, and social complexity. But its size and boldness create conflicts that limit long-term urban viability, despite the impressive adaptability. 2nd place belongs to the long-tailed macaque, whose tool use, problem-solving abilities, and proven success across Southeast Asian cities create sustainable urban populations where cultural tolerance exists. And claiming the top position, the rhesus macaque demonstrates unmatched urban primate success through extraordinary geographic range, proven populations in dozens of cities, exceptional dietary and behavioral flexibility, robust health, and a calibrated approach to human interaction that maintains precarious but functional coexistence. This ranking reflects current evidence and defined criteria, but reasonable people might weigh factors differently. Perhaps you'd emphasize cognitive abilities over geographic success, or value conflict avoidance over population size. The discussion itself helps us understand what makes urban adaptation successful and what challenges species face in human-dominated landscapes. Share your thoughts in the comments. Which species do you think deserves higher or lower ranking, and why? Have you encountered urban primates, and what was your experience? If you enjoyed this research-based ranking, exploring primate urban adaptation through specific survival criteria, please subscribe to Relax FAM for more calm, evidence-driven animal content. Share your experiences seeing primates in cities, and let us know what animal group you'd like to see ranked next. Understanding urban wildlife helps us create better strategies for coexistence in our increasingly shared world.